Hey Year 10. So what we've been doing recently is looking at quadratic functions. More specifically, we've been solving those quadratic functions. But now we're going to look more closely at the graphs. Okay, so we might see this shape here. This is called a parabola, and that's the graph of a quadratic function. That's the shape that the function makes. Now you might think, how come it has that curvy sort of shape? Why does that happen? Now, firstly, before I show you that, I just want to you to realize that this one here is the most basic parabola that you can get, which is y equals x squared. So just x squared. Um, they can be changed into different parabolas and look slightly different. But let's just focus on this one to start with and why it actually has this curvy shape where it turns here and changes direction. So what I might do over here is just think about each of these x values that I've listed along the x-axis and then substitute them into our rule to see what the y value is that goes with them. So if I have negative 3, if I square negative 3, that's going to give me 9. So 9's all the way up here. Right, there's one dot for us. If I look at negative 2, if I square negative 2, that's going to give me 4, which is just here. Next one, negative 1, if I square that, that's just going to give me 1, which is here. 0, if I square that, that's going to give me 0. If I square 1, it gives me 1. If I square 2, it gives me 4. And if I square 3, it gives me 9. Yeah. So hopefully you can see that these little dots, they're sort of forming that curvy shape, aren't they? Now, if we have all the other dots in between them, so all the numbers in between negative 3 and 2, it's going to create a full line for us. So that's why a parabola or a quadratic function gives a graph of this shape here. Okay. Now, as I said before, we can change what they look like. So they're not all going to be in exactly the same spot because we've seen other rules before, haven't we? So each different rule is going to look slightly different. Okay. Now, the different changes to the rule kind of come in three different categories. So the rule can be translated, and what that means, or the curve can be translated, what that means, it's either moved up or down or left or right. It can be dilated, so it's made wider or narrower. So instead of having this curve here, we could put some sort of dilation in, and the curve could end up looking a little bit like that. So it's been made narrower. Or in another case, another transformation, a dilation has happened, and it could make it wider, like that. Okay, so that's what dilation means. And reflection, it could be flipped upside down or flipped from side to side as well. So if we look up at this one, if this is reflected in the x-axis, which is this one here, that would mean the x-axis acts a little bit like a mirror. So instead of the curve being up here, everything that's up on this top half is going to move down here. So it's going to be moved to look something like that. So instead of a happy face, it looks more like a sad face. That's what a reflection might look like. But we're going to spend more time looking at that a little bit later. What we want to have a look now is the different, really important and key points that a parabola has. Now there's really four of them. So there's x-intercepts, there's y-intercepts, there's the turning point, and there's the axis of symmetry. Now the x-intercepts, that's where the curve hits the x-axis. So if we look over here, we can see that our curve goes like this, and it hits the x-axis at 2 points, there and there. So we could say that our x-intercept was at -4, and another one was at 2. Now when you're sketching, which is something that we're going to do later, I'm going to get you to always show coordinates like that, because that's something that you need to do in year 11 and 12. So there's your x-intercepts, and what you probably don't know is that's what you've been finding when you've been solving for x. Well, every time you solve for x with a quadratic function, what you're actually doing is finding the x-intercept. So you've actually been doing this already. All right, the next one, the y-intercept. Similar to x-intercept, except it's where the curve hits the y-axis. So here's our y-axis here. We can see that the curve hits where y is -8. So our y-intercept would be at -8. The next one, the turning point. So we can see that it starts going down this way and then it changes direction. up here. So the turning point is where it turns. So that would be this bit just here. So there's the coordinates of our turning point. And lastly, the axis of symmetry. Now, the axis of symmetry is a vertical line that kind of splits the parabola down the middle. So it's always on the turning point. So the axis of symmetry is actually this line here. So what you'll see is it's symmetrical. So this side is the same as that side. So the axis of symmetry in this case would be where x is minus 1. And as I said, it's always just where the turning point is. Now, one of the things that you're going to have to do is recognize where all these different things are. So it might show you a graph and you'll be asked show all these things. So all you need to do is be able to look at the graph and point them out, which is what I just did then to show you. Now, we might not have to find x-intercepts and y-intercepts from rules just yet, but when we do, what we really need to do is just make y equals 0 if we're finding the x-intercept, and then solve. To find the y-intercept, you're making x equals 0, and then solve for y. So I don't know if you have to do that just yet, but you will later on. So with this one here, I didn't point towards it before, but that has this specific rule here. So if we're trying to find the x-intercept, make y equals 0, solve for x. If you're trying to find the y-intercept, make your x's equal 0, and solve for y. With the rules that you're given, such as this one here, you can actually find any point along the line, which I've got written down here. So let's just try to find where maybe x is 1. Where x is 1 is about here. So I want to find this point on the line. Now I'm going to show its coordinates. So x is 1, and I don't know what the y value is. So I want to find that right now. So if I make x equal 1, so I change all the x's to 1, I should be able to find what the y value is at that point. So that gives us 1 plus 2 minus 8. So y equals minus 5. So therefore, the point that we found was when x is 1, y is minus 5. And we could have done that with any point along the line. We could have chose minus 3, we could have chose minus 2, whatever you like. Okay. What I might do now is I'm going to show you a parabola on your calculator, and we're going to kind of experiment and see what happens when we change the different numbers in it. So we're going to be looking at what makes it translate, what makes it dilate, and what makes it reflect. Right, Yew Ten. So I'm going to get you to grab your CAS out so you can kind of experiment along with me, because that's going to help you use your CAS better, and that's something that you absolutely have to do because it's worth probably 2/3 of your assessment going into VCE. Alright, so I'm going to start a graph, and I'm just going to graph our most basic parabola, which is x squared, which we were looking at just before. Okay, and that's what it might look like. But what I'm going to do here is start making changes to the rule to see what actually happens to it. So I'm going to leave my x squared there just so I can, I don't know, make comparisons. So at my next one, I might do x squared, but I might say plus 2 or something like that and see what happens. Can you see that the one with plus 2, which is the red one, it's just been moved up 2 units? So this blue one, it had its turning point at 0, 0. This red one, its turning point's been moved up to where x is 0 and y is 2. Let's change that again and see what happens. So instead of plus 2, I might change it to minus 1. Right, do you see how if we compare x squared and x squared minus 1, the minus 1 has been moved down 1 unit? So if you're adding on anything to the end, it's going to move it up or down. All right, let's see what else we can do. Let's just get rid of this for now. Let's go back to just x squared. All right, what I'm going to try to do now is try to move things to the side. So I'm going to put my x squared here, but what I'm going to do is put a couple of brackets around my x. Now, what I might do is write in minus 3 here and see what happens. Do you see how the whole thing has been moved 3 units across to the right. Now, I put in a negative sign and it moved it to the right in the positive direction. Let's see what happens if I put in a positive sign instead. So I'll do plus, let's do a different number, I'll do +4. Do you see how that moved it 4 units to the left? Right, so the number shows you how far you're moving, but the sign is showing you the direction, and the directions are actually opposite. Okay, so we now know how to move up and down. We also know how to move left and right. So that's how you'd translate a graph, or how they move around from side to side, up and down. Let me get rid of this one now. I might try something else. Let's just put our x squared in. Right, now I might put a number out the front. Let me just put a 2 out the front. Do you see how if I put a 2 up the front, it's kind of made it a bit skinnier? So what that's actually done is it's dilated all the points times 2 from the x-axis. So anything that was down here has been stretched upwards. So I'm going to put another number in there and see what happens. So if I put a 4 in, see how it makes it even narrower? So the larger the number that I put in, the narrower it's going to get. Let me change that 4 to maybe something a bit smaller. Let's change it to half. And see what happens. See how if I made the number half, it's made it wider? Right, so if the number's greater than 1 and is getting larger, it makes it narrower. If the number's between 1 and 0, it kind of makes it wider, doesn't it? So I might change that to a quarter and see what happens. It's made it even wider. So that's dilating it. All right, now let's get rid of that. Okay, now the next thing I might do is I'll add a negative there and see what happens. So I'll put a negative out the front. Do you see how that sort of flipped it upside down? So what's happened there is it's reflected in the x-axis. So the x-axis, which is just here, is sort of acting as a mirror, and it's flipped it upside down. So I've flipped it upside down. If I want to flip it upside down and then move it up by 3, I can add a 3, just like that. If I now want to move it, let's see, if I want to move it 2 to the right, I would say -2. There we go. See how lots of changes are happening? And if I want to make it maybe a bit narrower, I might change this to a 2. There we go. So what's happened just then is I've shown you how to translate up and down, left and right. I've shown you how to dilate your parabola as well. And I've shown you how to flip it upside down with reflection too. So what I'm going to get you guys to do, before you have a go at any of the questions, just do what I was doing on your CAS and see what happens. Have a bit of an experiment and see if you can kind of work out how it works. I know I showed you, but if you practice yourself, it's probably going to make it way easier for you to remember.